Hey math friends, let's go ahead and check out how we're doing on this study guide here. So this is for our statistical questions and plots. And we have a statistical question where we want to ask, we're thinking of like asking to a group of people, right? And we want to get data from it, right? Okay, so when we say what is your favorite animal, we're only asking one person, and really not a statistical question then. Okay. Part B says if it's not statistical, rewrite it. So first choice, oh, that can't be right. What is my favorite? No. What is the teacher's favorite animal? Again, that's individual. What is the favorite animal of all of the sixth graders? So there we're going for a big group. We're going to get lots of data there. How about this one? What video game console does Luis like best? So again, we're asking one person an opinion. Let's make it so that it is, so we can skip that part that says it is. What video game system does Mr. B like the best? Again, that's individual. What video game system does the class like the best? I would agree with that one. What video game system is coming out next? No. So it's got to be just C there. All right, same kind of question here for a couple more. How many students per grade level are in the band? Oh, so I got students per grade level. So I've got a whole bunch. That is statistical. So we don't need to change this. It is statistical. It does not need to be rewritten. All right, number 4. Giamatti studied data from the following categories. Select all that give quantitative data. So things that we can count. Okay. Thinking kind of like numbers too, right? Exactly like having numbers. Okay. Types of Oreo cookies. So types. We're not looking at a number there, so not that one. Number of animals in the zoo. That would be quantitative. Amount of books in the library. Yes. Types of push-ups. No, if it said number of push-ups, then yes, but no. First names. No. So I've got 2 answers. Select all of the categories that give categorical data. So categorical meaning like types, kinds, types of things, kinds of things. Types of Oreo cookies, yes. Number of animals, no. Amount of books, no. Types of push-ups, first names. So it's really the opposite of part A. All right, here's our dot plot. So this shows amount of sleep, time in hours, and it says that each dot represents a student that responded to that amount of sleep. Okay. What do the 2 dots above the 8 represent? So let's find the 8. This means 8 hours. And we've got 2 students. There are 2 students who had 8 hours of sleep, yes. Our other options, 8 students. No, this means time in hours. 2 students and 8 pillows. Pillows is not even in here. That's just wrong. Why is there no number 11? So 11, this is in hours, right? One person said they sleep for 10 hours, but we don't have an 11 here. So really, 11 students had pillows. No. No student reported 11 hours of sleep. That's what we're looking for. I would hope that all the students had pillows, but nobody reported 11 hours of sleep. And then we had 1 student who had 11 hours of sleep, but we ran out of room. No, we're going to make our plot as, to fit everything we can. Identify the outlier. Explain what it means in terms of numbers of pencils. That's not right. We're thinking of students sleeping here. Okay? So let's look here. Outlier is something really far away from our data. So in general, our data is here. It's kind of following a curve like this. And I don't really see anything that's an outlier. An outlier would be like all of a sudden at 6, there's a whole bunch. Or I have a huge gap. I have nothing here, and then I have something. But we really don't have that. All right? So really for this one, there is no outlier. All right, let's go ahead and check a couple more here. So here's another dot plot. This time we have the x's. This one says, which of the graphs has a skewed left distribution? Okay, this is one that we can get mistaken sometimes. So skewed left means that it kind of tails to the left. So we're going to kind of follow these trends. So it kind of looks like a hill here. So does this one. Kind of like drops here. This one kind of like curves like this. All right. So skewing left would be this one right here, where it tails to the left, or decreases there, but only to the left. This one goes left and right, so this is symmetric. Okay, we're gonna write these in for notes. This one is skewed right. This one's skewed left. This one's generally symmetric. About the same on both sides. If we cut it down the middle, it looks about the same. Okay? So the question is skewed left, that would be this one. Okay? And then we have this, graphed with approximately symmetric distribution. Oh, so I have another question here too. So this one is graph 3. So I have two questions here. This was kind of tricky. So this one is going to be graph 2. Over here is graph 3. All right. Next one, I got another dot plot, right? Shows the number of brothers and sisters a number of students have. So number of brothers and sisters, and then each dot represents a student responding to that. So like this one, the person has, these two have no brothers and sisters. These three have one brother or sister each. What is the distribution of this? So if I look here, okay, it's generally symmetric, about the same on both sides. Explain what the distribution tells you in context of the problem. Okay, so we can say this means that there's a, trend of some students having few siblings, some students having more siblings, and then in the middle, we have some students having many siblings. Okay, so we can say that some students have 0 or 1 sibling, about the same as having 3 or 4. Our mode is found at 2 siblings. So that's how we get that generally symmetric distribution there. All right, a couple more to check out here. Here we got a stem and leaf plot. A statistician for a chain of department stores created the following stem and leaf plot showing the number of pairs of glasses at each of the stores. Okay. Which of the following is an appropriate key for this plot? So let's check this out. 1, 3 means 18 pairs of glasses. Well, we know for stem and leaf 1, 3, that's got to be a 1 and a 3, not a 1 and an 8. So that's not right. 1, 3 means 1.3 pairs of glasses. Maybe. I'm using the right numbers now. 3, 0 means $30. 3, 0 means $3.0. Kind of confused on the dollars here, right? Let's check out what we have. So 1, 3. I have 1, 3, but that doesn't mean 18. I have 1, 3. That means 1.3. I can't see them selling 1.3 pairs of glasses. This says how many they sell, not like as an average, right? I think this is wrong. See, this one, I'm thinking this was an error on this, and let's go ahead and correct that then. This should be pairs of glasses. Yeah. Sometimes we get these assignments and there's something not right in there. What observations can you make about the information in the stem and leaf plot? Select all true statements. The most frequent amount of pairs of glasses is 47. So let's find 47. 47. That only comes up once. So that's not right. The most frequent amount of pairs of glasses is 16 and 43. Let's check those. 16 comes up twice. 43 comes up twice. Nothing comes up 3 times, so yes. The data is approximately symmetrical. Let's see. So if we go like this, and then it drops down and then it goes back up. Yeah, I wouldn't say that it's approximately symmetrical because of the changes in that curve there. The data is right skewed, so it skews off to the right. If I kind of like think of it as a dot plot, no, it really isn't. The range of the data is from 9 to 47, or a difference of 38. Okay, let's see the range. Smallest number is 9, largest is 47. So 9 to 47. Ooh, they try to trick us down here, 0 to 47. So really there's only 2 answers here, B and E. All right, check out number 9 here. Histogram displays the shoe sizes of students at Jefferson High School. Use it to answer the questions. Describe the data represented in the histogram. What does the title tell you about the data? Okay, so the title up here at the top, that's where I find it. Title. Okay, so we can say the title tells me we are studying shoe sizes at a high school. This is important for probably like shoe companies to know and people who sell them parts to make them, really, because they want to know, for these people, what do we need? What does the label on the horizontal axis tell you? So horizontal, left to right, sideways. Okay? So we can say the label shoe size tells us that shoe sizes are found horizontally on the graph, right? So my shoe sizes, I get 6 to 7, 7 to 8, 8 to 9. Are the data represented in the histograms bars discrete or continuous? So the histograms bars. Okay, so let's think about this. Shoe sizes for students. If I'm thinking about students, can I have a fraction of a student? No. So discrete, you cannot have a fraction of a student. I'm kind of agreeing with that. Okay? Discrete, you cannot have shoe sizes such as 9.5 or 8.5. Well, you can, so I do not agree with that. Continuous, you can have a fraction of a student. No. Continuous, you can have shoe sizes that such as 9.5 or 8.5. So this is true, but for this there's only really one answer, right? It's either discrete or continuous. Because we're looking at, we asked students for it, right? I can only have 1, 2, 3, 4, 5, 10, 31, 32, 33. I cannot have a fraction of a student, so I'm really looking at A. Number 10, what is meant by formulating a statistical question? The first component of the statistical process. Okay, so in this one, we want something to the effect of formulating a statistical question ask, and remember, we're asking the individual or a group. We're asking a group. We'll ask a group of people for data to inform or solve a problem. Give an example of a question that is statistical and a question that is not statistical. So for this, I would think if you have anything that relates to what you know. So I'm going to go start with statistical. Okay. I'm going to say how many Squishmallows do middle schoolers own? So we would ask all of the middle schoolers. We'd get a lot of data on that. Okay. I'm thinking of something not statistical. Okay. Here I'm thinking of the individual level. I'm going to say how many Squishmallows does Mr. B own? So here you're only looking at one person. All right. So hope that helps, and pause, rewind, go through that as you need to.